Good morning or good afternoon, depending where you're located, and welcome to the SolidView webinar. My name is Tom Borgich. I'll be doing the webinar today, and I'm going to start with a short overview of SolidView. And if time permits, we may be able to open it up for questions, although I'm not sure I know exactly how to answer questions, but if they pop up, I will try and answer them. Okay, so we're going to start off by just saying, what is SolidView? And maybe the best way to define SolidView is to say that, what SolidView isn't. And it's not meant to be a CAD system or anything like that. It's not for designing or creating new designs. It's for viewing and interacting with existing design data. And it's really designed to allow people who normally would not use a CAD system. In the past, they might have used a 2D drawing. It's a way for them to view and measure and interact with the 3D data without needing to learn how to use a CAD system or purchase a CAD system. And we actually have two main products we're going to talk about. SolidView Pro, which is really our flagship product, and it does the 3D viewing, measuring, and markup, and it has direct CAD interfaces. And then we'll also talk briefly about SolidView Pro RP, which has all the features of SolidView Pro. In addition, it has some specialized rapid prototyping tools. So here's an overview of the SolidView family of products. We actually have a free product, which is called SolidView Lite, which is kind of like the Adobe viewer of SolidView. It allows you to view data from a couple of different CAD systems and also from SolidView without actually having to purchase a license. Then we also have a $99 viewer that adds some measuring capability, and that is just called SolidView. And then our two main products are SolidView Pro and SolidView Pro RP. And perhaps the best way to understand the differences is to look at some of the functions that each one has. And all of them can view STL files. SolidView and the Pro products can actually view and measure STL files, and the Pro products give you the ability to do some modification. Again, SolidView Lite lets you view SolidWorks data and VRML data, which you can also view and measure in SolidView. And SolidView Pro gives you that same functionality with the ability to modify the STL and the VRML data. And then finally, the Pro products provide direct CAD interfaces to a number of different CAD systems. We've listed some of the more popular ones here. There are actually quite a few other ones, and you can check out on our website if you need to know information about a particular CAD interface. And then last but not least, SolidView has its own format, which is a SolidView document, and all of the products can view that data as well as measure it. And again, it gives you some modification functionality in SolidView and the Pro products. So who uses SolidView? Well, it's used by, again, just about anybody that might normally look at a 2D drawing. Some of the most common users are estimators. Those could be people doing cost analysis within an organization, or perhaps sales people for a custom manufacturer. It gives them the ability to look at parts and assembly, identify design features that may add to the cost, sometimes make recommendations for manufacturability and so forth, then ultimately come up with a quote to manufacture those custom components. It's also used extensively in manufacturing organizations for design for manufacturability analysis. You can now view what's commonly called product manufacturing information, or PMI, which is just like the GD&T information that used to be on a drawing, but it's now embedded inside the 3D CAD models. And as I mentioned earlier, we've got special functions for RP users, or rapid prototyping users, and that's the ability to repair STL files, section large parts, and do some thin wall analysis. And that thin wall analysis is also useful in other applications such as injection molding and so forth. And then it's often used by designers just as an easy way to communicate designs across different organizations, companies, time zones, conduct design reviews. Particularly that it's particularly helpful when it involves components that are created on different CAD systems, because you can bring them all together inside a SolidView. So that really sums up the PowerPoint part of this, and what we're going to do now is actually take a look at these various functions inside of SolidView. So I'm going to start by loading up a relatively simple file just to give you an idea of what you can do in SolidView. And the first thing you often want to do when looking at a part is just get an idea of what that thing is. There's a number of ways to do that, and it's very intuitive to be able to just spin a part around as if you had something in your hand you want to understand it. And using these buttons in SolidView, you can easily rotate the view in any direction, twist it around. You can pan and zoom with these buttons. And we have a number of standard views, like an isometric view and so forth. But one of the things that I find most useful is just right-clicking on the display and moving your mouse operates like a kind of a virtual trackball, and it makes it very easy to spin the part around and get an idea of the features of this particular part. SolidView also has a number of different display modes. This is in what's called a flat shaded mode. I can put it in a smooth shaded mode, which improves the rendering a little bit. You can also put on what's called surface edges, which tends to draw lines on the edges, and it makes things stand out a little bit more. And that's typically how I have SolidView set up, just because it seems to give the best rendering and gives you the best idea of what kind of parts you're looking at. Now, the next thing people typically want to look at is, want to understand is just, how big is this part? And that's where the measuring functions within SolidView come into play. And up here under the measuring and markup tab, I've got a number of different measurement functions. I'm going to right now just click on this object measurement. And what's going to happen is SolidView is going to display the basic dimensions of this part. I'm going to put it back into the isometric view, and I can get a good idea that this part is 1.256 inches tall and so forth. And just to give you an idea, you can also look at some other measurements in here, or mass properties, such as the material and the actual mass or weight of the part. Now, this part does not have a material assigned, so SolidView lets me right-click on that, and I can actually set the material. So I'm going to go ahead and let's just say that this is an aluminum alloy, and we'll go ahead and apply that to this part. And now you can see I now have the material set as aluminum alloy, and the mass is 0.299 pounds. To give you an idea what this thing is going to weigh. And all of this is customizable as to what displays in that panel, even if you want to display it or not. It's also all available over here in the area that we call the Active Directory. And if I need to, I can actually copy all this information to a clipboard, so I could post that into an Excel spreadsheet or into a Word document or anywhere else that I might need to use this information. And for those of you that typically work in something other than inches, you can also change all of this automatically. So if I go over to Modify and say I want to display this in millimeters, I can go, and by clicking on that, now all my measurements are displayed in millimeters. My mass is displayed in kilograms. I'm going to go back to inches because that's what I'm most used to. That gives you an idea of the overall dimensions of the part. Now, if I wanted to save some of this information, one thing I can do is save this scene, which is kind of like a PowerPoint slideshow. So I'm going to go ahead and save that scene. Then I'm going to erase all of these measurements, and we're going to take a look at perhaps some more detailed measurements or feature measurements. So what we'll do is, the easiest way is we have a number of measurement tools up here, like measuring distance and angle, arc, and so forth. We've added a new feature that we call the quick measurement, and I actually find that very easy to use. And under quick measurement, I've got a couple of options. I can measure the object, I can measure a distance, angle, arc, and so forth. So right now it's on measure distance. And what will happen is, as I zoom in on an area, and I can use the mouse wheel to zoom in, if I go to take a measurement, SolidView will highlight anything I put the mouse over. So if I go over this arc and click there, and then this arc and click there, so I missed my first one, SolidView will then take the measurement between those two arcs. But it could be anything that I want to highlight. So if I want to measure this arc and this edge, and it's warning me that that distance isn't parallel because they may be at different heights, I'll get that measurement. Or it could be from this edge to this edge, or from this face area or plane, and I can rotate my view a little bit and do this one here and get that measurement. And this makes it really easy to quickly create another number of distance measurements. And again, I'm going to go ahead and save that scene. Actually, I should save that as a new scene. And I'll go ahead and erase all that information. And let's say I wanted to measure an arc or a diameter. I can use that same quick measure tool and pick up either a full radius or a partial radius. And again, most of the angles on here look to be 90 degrees, but I could use a similar function to measure angles. And as I suspected, that was 90 degrees. So SolidView gives me quite a few very easy to use quick measurements. If I need to do something more complicated, I can use the distance measure tools, and that allows me to measure from things like points and lines, and I can actually construct geometry if I need to do that, which is sometimes necessary if you're dealing with a particularly complicated geometry. One of the other things I can do is a very handy feature is the thickness measurement. And what this does, and this is particularly important for things like injection molding and so forth, where wall thickness is critical, anywhere I click, SolidView is going to do a distance measurement. So you can see it's 80 thousandths there, 80,000 or 43 thousandths, 430 thousandths there. And this is a very easy way to quickly identify areas that might be problematic in injection molding and so forth. I must have hit a boss or something underneath there, and that's exactly what I did. Because most of this is 80 thousandths thick. So that's just another series of measurements I can take. If I really want to highlight something, I can go ahead and put some paint on it and add some other additional notes or information. So let's say that this surface area, this surface here needed to be treated in a particular way. I could go to my Tools menu and under Paint, just say that I want to paint a face, and right now it's yellow. I'm going to go ahead and paint that face yellow. Now you notice that the whole part changed. That was because I had that part selected and its color, the select color set to blue. The minute I go into paint mode, though, I don't want to overwrite the select color. I want to kind of show the true color of the parts. Now if I needed to, I could also put additional information on here that might indicate what needs to happen to that surface. So maybe I'll go ahead and put a note and say, something to the effect of this surface is to be treated per spec, something along that line. And if I really wanted to highlight it, I could even draw an arrow from there to here, and that way I can make it very clear what I'm trying to communicate to somebody. Might also help here if I went through and expanded this text box a little bit. And I could go ahead and save this scene also if I want to use that later. One of the other nice things about SolidView, I'm going to go ahead and erase all of this, is the ability to make section views and take measurements off of those. And that's a function underneath our measurement tab. And what the section view does, it allows you to pass a section plane through the part and basically visually cut it in two. And I can do this along any particular axis or any angle that I might need to do so. Right now I'm cutting this along the z-axis, it looks like. And I can go ahead and just show part, one half of the part, and I can move that anywhere I need to understand what I'm trying to do. And once I have that section defined, I can actually go back to my measurement tools, measure distance if I wanted to. I'll zoom in on this, and I can actually take a measurement off here. Now, if I just do a measurement of a line a line, it's really going to be just like doing a thickness measurement here, but it gives you an idea how the function actually works, how the sectioning function actually works. And again, I can save that scene if necessary. And the whole idea behind the scenes is I can go back to here and step through and see any of the scenes that I had previously created. So this is how I might create a kind of an interactive design review, save this whole thing, and send that off to somebody else, and they can look at the measurements I've created, view everything that I've done, and if necessary, take any additional measurements or mark up any other changes that they might want, or make any other markups that they might want to do. So that's a brief overview of the sectioning or the measurement and viewing functions of SolidView. I'm going to bring in a different file and show you a couple of other more advanced tools. And what we're going to look at right now is what looks like more or less a typical injection molded part. And I'm going to show you the mold analysis, or what might better be called draft analysis. And what I'm going to do is I'll go into the Tools function and select Mold Analysis. And it's going to show me the Z-plane, which is the pull direction for injection molding. And what this shows over here are the different areas that I can identify. And I'm going to click on that. I want to show undercuts and vertical surfaces. This shows my minimum draft angle of 3 degrees. I can adjust that as needed. And I'm just going to go ahead and apply that, which will do the analysis. And right away what it does is it highlights these areas in red. Obviously, if I was pulling a mold along this Z direction, I would need some sort of an insert or slide for these areas. And if you know anything about injection molding, adding inserts and slides, of course, is what adds cost and complexity to the mold. Now, if I wanted to communicate this to somebody, I can actually save this as paint, or what I find very easy to do is just go in and right-click and say, Save Image, and I'll go ahead and save that, and save that image. And then what I can do is SolidView then allows me to take that image, and I can just drag that back into SolidView as an image file, and I can even add notes and markups to that. So if I wanted to describe how they should go about changing this design to perhaps reduce the number of slides or inserts that are required, I could easily communicate that to somebody. Now, I'm going to go ahead and clear all of this out of here, and I'm going to show you another one of the advanced tools, which is the 3D file compare. And what we're going to do is I'm going to load a second file, very similar to this one. It's oriented a little bit differently, and I want to find out how these are different. And this is very common, particularly when using modern parametric modeling systems, that somebody will go in and make a change, and it perhaps changes something they didn't expect to change, or you get a new file from a customer saying, oh, it's only a minor revision, but it turns out they forgot to tell you about one of the changes, and so you missed that on your estimation, or actually even worse, when you actually build the parts. So we have this tool that allows you to compare these two files. So the first thing I'm going to do is go in and I'll go to the Tools menu, and I've got Compare Objects. I'm going to go ahead and do a Control-A, which will select everything. And I've got my two parts. They're not oriented correctly, but I've got an auto-align function here in SolidView that'll figure out, in most cases, how these two parts should be aligned so I can visually easily compare them. So I'll go ahead and do that. And then down here, I've got an Analyze function. I'll go ahead and click on that. And what SolidView is doing is comparing the two parts and highlighting areas that are different. And in fact, you can see down here that the green indicates plus, meaning material was added. And if I zoom in here, I can see the green right there. And it's not indicated here anywhere. I don't think, oh yeah, there's also another change here. And if I actually go ahead, I can save this information if I need to. But if I go ahead and I'm going to close the file compare function, and we'll go in here and we'll actually just do a couple of measurements on these. So I will go to my Measure tab. I like to use the quick measurements and distance. And what I'm going to measure is from the top of that boss down here, and that's 0.399 inches. We'll do that on this one also. Try that again. Make sure I pick a flat area. It's not the measurement that I wanted, so I'll go ahead and actually undo that. And let me straighten this out a little bit better so we can get an easier view. So we're going to go ahead now and measure from there down to here. And it's 0.39 again. And we'll do that same one over here. And I think we'll see, obviously, that they're of different sizes or different heights. That's 0.3. So I won't bore everyone by doing multiple measurements. But this is obviously a very simple case. But when you get a complicated design, especially if you're dealing with certain castings or injection molded parts, it's critical to be able to identify what's different between each of these parts. So I'm going to go ahead and clear that out. And the next thing I'm going to do is show how you can use SolidView to view an entire assembly. In this case, what I'm going to do is load in a Pro Engineer assembly. This is a Pro E Wildfire file, and I'm going to go ahead and read this in. And what SolidView is doing is it's actually reading all of the native CAD data for this Pro E assembly, and it's going to load each of the components into SolidView and render them for me, as you can see here. And this is a fairly simple assembly. It's a drawer slide. It's actually a fairly high-end drawer slide that would be used in computer rack equipment and things like that. Now, one of the nice features of SolidView is I have the ability to actually show the assembly tree here in SolidView. Here it's fully exploded. I can do all kinds of things. I can actually copy this assembly tree, export items, things like that. Anywhere I click on the object is going to highlight it inside the assembly tree view, and I can then actually hide that. I can hide that whole subassembly. There's all kinds of things I can do within this assembly tool. If I click anywhere here, like a particular ball bearing, SolidView would highlight that, or I can click on this component, and I could say that I only want to show that component. There's all kinds of manipulations I can do in there to work with that assembly. I can also do measurements from one part of the assembly to the other part of the assembly. It makes it very easy to deal with complicated assemblies and understanding exactly where you are in the assembly tree, just as you would within a CAD system. So that's a very easy way to work with complicated assemblies. I want to show you a couple more CAD interface items. I mentioned earlier about the PMI data, or product manufacturing information. And what I'm going to do now is load a file from CATIA that actually contains this PMI data, or geometric dimensioning and tolerancing information. And so here you can see the actual PMI data from the CATIA system. These are all rendered as 3D measurements, just as they would appear in CATIA. I think there's actually a couple of different views of this same data that comes in from the CATIA file. And this is important because more and more manufacturers are switching to using PMI data instead of actually creating 2D drawings to document all the manufacturing information. So that pretty much covers the basic functionalities of SolidView Pro. I'm going to talk a little bit about some of the SolidView Pro RP functions. And I'm going to go back to a part that I think you've seen before, which was our base, our injection molded part. And let's say that I wanted to build this on a rapid prototyping machine, but it was too big to build on this machine. Well, SolidView Pro RP provides a function that allows you to cut this part. So I'm going to go to my Tools menu, and what I like to do on this is actually just get a kind of a straight-on view of this. And if I go into the cut function, there's a couple of different things I can do. I can do a very simple planar cut, which would just slice it this way. Or if I select the compound option, I can pick different types, like a sawtooth, so forth. This one seems to be a common one. I'm going to actually rotate this 90 degrees because I want to cut the part this way. And there's lots of things I can do when I click on this. I can actually kind of move it around or change the size of the sawtooth. If need be, maybe I like this size, but I want to move this particular point a little bit just because I don't want it interfering with that feature. I can kind of spin it around and get an idea how it's going to look when I cut it. That, to me, tends to be a little bit confusing. What I like to do is once I think I have it right, I can just go ahead and say cut. SolidView will cut that into 2 parts. If I didn't like what happened, I could just click on the undo button and it'll completely undo that and get me back to where I was. So now what I've done is I've cut this into 2 parts that can only fit together in one way, and I can actually go to my modify function, and if I click on this, and let's see, we'll do modify move, I can grab this and pull this out of the way, and you can now see that we actually have 2 separate parts that can be built on a smaller rapid prototyping machine, and then reassembled only one way. So I'm pretty much guaranteed to assemble it the right way. I'm going to show you a couple more RP functions. What we're going to do now is some what's called the thin wall analysis. So I want to make sure I've got the right part here. Here's a test part that we've used, and one of the problems with certain types of rapid prototyping systems is that they can only handle wall thicknesses down to a certain amount. So it's important to identify up front if you've got wall thicknesses below that amount. Under our Tools menu, we have a wall gap analysis, and this right now is set, the minimum wall thickness is set to 80 thousandths. I'm going to change that to 40 for our initial test here. And I'm going to go ahead and do the analysis. And what that'll do is highlight in red any areas that are potentially under 40 thousandths. And you can see it's highlighted here because this thin area here and right here has a wall thickness of less than 40 thousandths. Now, if I wanted to, just as a demonstration, I'm going to change that back to 80 thousandths. And I'll do the analysis again, and you'll see a lot more areas are going to be highlighted, more specifically each of these depressions. And if I actually went in here and went back to my measure functions and did a measure thickness, you can see right here it's over 80 thousandths, and here it's under 80 thousandths. So it's actually doing the proper analysis. And if need be, I could have saved all that coloring so I could show somebody else where the problem areas exist. Let's see, I think we might have a little bit of time to show you some of the repair functions of SolidView. And I'm going to start with a very simple test case. And if you're familiar at all with rapid prototyping and STL files, you know that there's certain requirements on the STL files that they have to have certain vertices line up. And ideally, you only want to have one shell, which means you want all the triangles to connect to another triangle. And SolidView gives you some tools that will not only identify some of the problem areas, and what this is indicating here is that these shells, the vertices do not line up, and we have all these multiple shells. And I can actually select one of the shells and hide it. I could remove it, separate it. There's all kinds of things I can do in the repair tools. I actually have some manual repair functions to delete certain things and add triangles back in. We don't really have time to go into a lot of the repair details, and fortunately the good news is you really don't need to, because in most cases all you need to do is click on the repair function and SolidView will go in and repair that file so it now has all the vertices lined up, and there's only one shell, so it's a good STL file for rapid prototyping. That was a very simple example. I'm going to show you something a little bit more complicated. Something that has a few more triangles. That says just under 200,000 triangles. And if I go to Tools, Repair, you can see I've got quite a few shells. Some of the shells are good, which means that they are connected to themselves correctly, but you typically wouldn't want that many shells in a part, and you certainly don't want that many shells that are not complete. Again, there's a lot of things I could do manually with this. Most of the time, clicking on the repair function automatically corrects all the problems. So I can see we're just about out of time here. Again, I thank you for attending the webinar. I think you'll be receiving an email regarding how to receive a discount on any purchases for attending the webinar. And thank you, and enjoy the rest of your day.